because it will be useful for you also. Okay, so we just finished that, actually, exponents, logarithms, and related functions. Basically related functions is what we finished, is done. Okay, so we will go ahead with something called absolute functions, or modulus, we call both same, modulus functions. So what we mean by absolute, and just like the way we did the exponents and the logarithms, so in the absolute also, first we'll give the arithmetical meaning. Like, what does it mean actually when we say like this? This is read as modulus of -5. This is how we read it. That's how we read it. Okay, or in the short form we can read it as mod 5, mod -5. This is how we read it. Okay, so what the value of it, actually the value, when you evaluate, the value of this equals to 5. Okay, so that means negative is ignored. You are taking the absolute value. You are taking the absolute value. You don't bother about negative. So if I have modulus of 5, that's equal to 5. Modulus of -5, that's equal to also 5. So an absolute function, if you have function, meaning you, instead of this number, you will have a something like this. So f of x equal to this. So this actually do not mean that that's equal to x. Instead of saying that, okay, f of x will always be positive. This is a better way to say it rather than saying it is x. So what actually always positive meaning, whether x takes positive value or x takes negative value, whichever way f of x is positive. That's what this means. Okay, so, and if we actually look at how do we plot this, okay, so in order to actually sketch this graph, we just have to see first what is f of x equal to x looking like. What is the sketch? For example, sketch this f of x equal to x, and from that we have to sketch f of x equal to mod x. I didn't even put negative x, I just said mod x. Okay, this is it. Okay, now in the same way, just like the way we got this f of x equal to negative mod x or whatever, we can also have f of x equal to mod x. Okay, so what is the big difference between this and this? We will see. Okay, so first thing is, for f of x equal to x, you have nothing but y is equal to x. This is nothing but y equal to x. So y equal to x is a line passing through the origin like that. Okay, I'll just write it as a straight line. So this is y equal to x. This is y equal to x. So what? Yeah, y equal to mod x. Y equal to mod x. So as we said, right, there is no negative value. So which means you have this part, right? All this part you will shift it to the other side like this. Exactly the mirror reflection about the x-axis. Yeah, this is our x-axis, right? So this will be the mod x graph. So mod x graph will be something like this, like a Nike symbol. Okay. So you always have a like that. So this is mod x. Okay. So then you may ask, how about if I have mod negative x? Obviously, whatever x value, so this all boils down to actually making a table and then how it looks like. Okay. For example, I have f of x equal to negative mod x. Okay, so now I have to make a table for this, and what are the values I can give, and this is just like the way we plot the graphs, right? So we take x value, different values of x, and then okay, so I'll give the different values of x values here, and I have put the f of x value here. Yeah, table. Let's suppose x equal to minus 5. So x becomes minus 5. You get here f of minus 5 equal to mod of minus 5. That's equal to mod of 5, which is anyway 5. It's 5. Yeah. So let's take any other value like 0. So f of 0, its mod of 0 is 0. There is no negative 0, positive 0. It's 0. So it's 0. So now I'll take 1. So f of 1 is modulus of negative 1. That has to be, by definition, it is 1. Therefore you have 1. And then you'll take a value 5. So you will have f of 5 equal to mod of negative 5. That's equal to 5, because by definition it's a positive value. Yeah, because minus x, right? Our function is minus x, you see, minus x. So minus 5 you have to write, and you get as a 5 only. So which means you got this graph also. If you plot it, you will have exactly similar. So you still have that one coming like that. So the important thing here is, let's suppose I have this as minus 5 and this is a plus 5. Both will actually have the same thing. Yeah, exactly. So you have the same thing. Okay. So that value is the 5. So this value is the 5. Okay. So that's how the mod x graph looks like. Okay. Or mod minus x, either positive or negative x. Inside you will have this. Okay. There will be again variations of how you will do it, like so in this graph you are seeing, we know the translations, transformations, and all the things, right? In fact, all these things, even for exponential functions also we need to be talking about. Okay, exponential and logarithms also we'll be talking about the translations and transformations. They work, actually they are valid. Okay, now look at the translation. For example, I have f of x now equal to mod x plus 2, mod x plus 2. So simple way to remember is, this is 0. Okay, so this is 0 because you just have mod x. There is no other number added to that, isn't it? So there is no x plus 2 and all, which means you equate this to 0. Whatever is within the mod equate to 0, minus x equal to 0. That means x equal to 0. So you will see that this part, right, the tip coming at 0. Tip is at 0. Okay, so in this case, now come back to this and say, oh, I have the x plus 2 here. So you equate x plus 2 to 0. You have x equal to minus 2. So the tip will be at minus 2. So that means you are shifting this to the left, which we know it anyway, translation, right? that's nothing but shift left. Shift left. Okay, so you have the same graph, and now you just do that and go like that, and this is -2. Okay, so that's how the graph looks like. Then you will have again scaling up, scaling down, which means you can have a mod of 3x. It can be like f of x equal to mod of 3x, or you can have f of x equal to mod of negative 3x, or you can have f of x equal to 3 mod x, and f of x equal to negative 3 mod x. Okay, so many variations are there, and which one of them look exactly same? These two are exactly same, like A, B, C, D. When you sketch it, sketch of A and B identical, no change, because automatically whatever is a negative you have inside, it automatically becomes positive, therefore there is no change inside that. Okay, in fact even C identical, because whether this 3 is inside or outside, not a big deal, because we are anyway multiplying with the 3. But then yeah, the D is different. D is different because it has only negative value. Yeah, outside you are multiplying it, because this is outside, right? Outside the mod. So what does it mean? So it's very simple. If I have f of x equal to x and another one g of x equal to negative x, okay, so this, if you look at that, like y is equal to mx plus c form, here you have plus 1 here as a coefficient. That means this is a positive gradient or positive slope. This is a negative gradient, right? So if I draw the graph, you will have so this is g of x and this is f of x. One is a positive gradient, other one is a negative gradient. Yeah, it's minus x, meaning like that. Okay. Yes, correct. This y is equal to minus x. Y is equal to minus x. This y is equal to plus x. Okay, so what we understood is that it's basically shifted, that is without the mod. Okay, if you have a mod, both are same. That means if I have f of x, yeah, we just saw that, right? Mod x and g of x is equal to negative mod negative x, both are exactly same. The graphs will be same positive. But if I have this negative number outside, how does it translate? Okay, so if I have that, then you have a graph of and say this is f of x equal to mod 3x, which means you have at x equal to 1, at x equal to 1, this value is 3. So if I have now g of x, another function, so if I have the g of x equal to negative 3x, so when x equal to 1, you are getting, so g of 1 will be minus 3 into 1, you'll have minus 3. So minus 3 somewhere here, right? So this line will be going now this way. So you put x equal to, got it, right? So and this line will have, probably will be going this way. So the g of x, yeah, g of x minus 3 of x. So here no positive value, no positive value of g of x. G of x is always negative. Got it, right? Okay. So these are that small variations. Then ask a question now. How can you comment on f of x equal to 3x plus 2, g of x equal to minus 3x minus 2. So the question is A and B are identical, or A and B are different? So you just have to do a little bit of algebra and then you should be able to give me the answer. What do you think? They are identical. Yes, this answer is correct. They are identical. Why? Because when you take this, right, you got minus of 3x plus 2. Yeah, as a bracket. Yeah. So whenever you say this is anyway same as this one, right? So we could write then g of x equal to mod minus f of x. Okay, so this is a different way of writing, but this means the same thing. Okay, so that's the reason both are identical, right? Okay, so this is the general overview of the absolute functions, and as I said, if you go ahead with the translations, transformations and all the things, that makes the whole story. Okay, now let us look at how f of x equal to mod x, f of x, okay, let me take this as a g of x, g of x equal to mod 3x, and h of x equal to x by 3. Okay, these are except for the mod, knowing that these are all positive functions. Okay, otherwise you can have these things even without absolute. I mean, you can have a similar thing like without this mod, x, 3x, x by 3. Okay, in this case the gradient either plus 1 or minus 1. Why we say or minus 1? That's exactly the graph, right? So we have this graph, the gradient is plus 1 here, the gradient is minus 1 here. Okay, now in the second case, yeah, okay, in the second case here the gradient or the slope is either plus 3 or minus 3. Now actually the question is, the gradient is plus 3, then do you think it will bend down or will bend up? Will it be like that, closer to this fellow or closer to this fellow? Will it be closer to x, closer or bend towards x, or away from x? X-axis, I mean. So when do we call something is steep? When you are going for a trek and all, when do you think you say, oh, this is a steep trekking? I mean, it's really too steep. Yeah, it's very closer to vertical, right? It's very close to vertical line, right? So Yeah, so that's why your line is actually closer to this, for example, when compared to the previous one. Then this is kind of a 3x. So it's just shrinking towards, okay, the y-axis. These are the scaling up, scaling down things, scale factor and all the stuff. Similar actually. Here, since it's a 1 by 3, so that means it will widen up actually. The graph will be, you will see here, because the gradient is less. That's why you will be. I'm just exaggerated. This is too much, too bent. Okay. So here the gradient is 1 by 3. Gradient is 1 by 3, and the gradient is negative 1 by 3. Okay. So these are the three different forms of the same function with the scale factor, the multiplication factor being different. And this is same as what we learned even for a normal linear function. Okay. So there is another school of thought, meaning what is actually when someone says mod x is something or whatever. Okay. So let's suppose they have mod x equal to 5. This actually means you square both sides. When you square both sides, yeah, you get x square on the left side. On the right side, you get a 25. So if you do not use calc, no calc, and then you want to find the value of x, it is nothing but square root of 25, and we put plus or minus, isn't it? Got it, right? So this concept many times, yeah, it can be minus 5 also, right? X value, yeah, x value. I'm telling you about x value. This is, yeah, this is called solution. When you say solve, right? Solve. X can be this, understood? But the mod x is always 5. This is the same graph as we, yeah, exactly. Yeah, it is the same graph as I said that 5. I had drawn one graph and said it is 5. This is x equal to minus 5 and x equal to plus 5. These are the two solutions. Okay, but then you have this is just 5. Okay, so how the graph looks like? Okay, let's go to the this one. Mod x equal to 5 is actually nothing but x equal to 5 line. So the graph of this is not that triangle or a Nike symbol. This is this x equal to 5. It's just horizontal line. Okay. Yeah. So this is x equal to 5. Rather mod x equal to 5, so mod x equal to 5, that means, so you got y is equal to something or x equal to 5. So for whatever you take and x is equal to plus or minus 5, you give it. So in fact you can't have this because he said mod x equal to 5, you are giving x value 5. You can't even plot it actually. Even this isn't correct. Okay, this isn't correct in fact. Okay, because this is not y is equal to mod x or y. Okay, what they had drawn was actually y is equal to mod 5. I just draw 5. Okay, that's a y value. When there is no y, then there is no, obviously, right? Okay, so now let's dwell something more on this. Okay, we'll go into the next page and we have solve mod of 3x plus minus 2 equal to 5. See, this is nothing to sketch. This is the solving, no sketching part. Okay, solving the x value. Yeah. So let's look at, if I just had a 3x minus 2 equal to 5, I would have said 3x is equal to 7 and x is equal to 7 over 3. One value. But then here, as I said, square both sides. That means you have 3x minus 2 whole squared equal to 5 squared. Then you have 3x minus 2 equal to either plus 5 or minus 5. So in case of plus 5, you get x equal to 7 by 3. In case of this, you'll have x equal to minus 1. Makes sense, right? So how do we check it? Let's put x equal to 7 by 3 anyway will satisfy this. Let's put this mod of 3 minus 1 minus 2. You get minus 3 minus 2. Yeah. What's your question? Can I repeat it? Yeah. So mod of, I'm substituting, I'm checking, I'm verifying this whether verify put x equal to minus 1. Yeah, you substitute that value, then you get minus 5, and then you take mod of that plus 5. So you get the plus 5 for two values of x. So that's what, if they give solve this, okay, so you got two different values for x equal to minus 5 as well as plus 5. I'm sorry, x equal to 7 by 3 or minus 1. Okay, so you may be now wondering, how come these two are different? We were doing actually, when we say like it looks like a symmetrical, I have drawn like this, I have drawn like that, and I put minus 5 here. Okay, I put some plus 5 and I got minus 5. So both, this is where I got the same value is what probably you may argue. But that is for mod x. But this fellow is not mod x, right? This is a shifted version. Correct? Because the translated version definitely will not have the symmetrical x values. Okay, yeah, it will be different. Okay, now I'll give you a question, you can try it. Okay, try solving it. So question, mod of minus 7x plus 2 plus 3 equal to 7. Solve for x. Yeah.
So here do I make that do I have to square the 7x plus 2?
Yeah, so you got minus 7x plus 2 equals 4.
Yeah, 4.
Yeah,
So
actually, yeah.
square that.
Yeah, from the working perspective, if you are to show the working meaning, so when you square it, square both sides. So you have minus 7x plus 2 whole squared equals 16, 4 square. Then you could take off minus 7x plus 2, that means again square root both sides, equal to square root of 16, and you have to write plus or minus 4. This is the step. Then equate 1 to plus 4 and equate next time to minus 4, and you get a different x value. Okay, yeah. So
Substitute plus 4 and minus 4.
yeah, so you equate this, that means minus 7x plus 2 equal to plus 4.
And minus 7.
Yes, correct, two different values. That is for this. Minus 7x plus 2 equal to minus 4. This is for this. So if you don't have to show the working, you can directly come to this step. This step you can directly jump from this to this, because you are squaring it and square rooting it. So both actually, no big deal. Yeah. So,
Or you can from minus 4, that was equal to minus 4, then 6 by 7.
so x equal to minus 4, you get minus 6 by, so 6 by 7. Yeah, that's correct. Yeah.
Minus 2.
Yeah, got it, right? Okay, that's done. Good. So let's suppose you have y is equal to mod 2x plus 3 minus 5. So how do we sketch it? So we have to first take this 2x plus 3, and I said 2x plus 3 equals 0. That implies x equals minus 3 by 2. That means the tip is at minus 3 by 2. Correct? So yeah, so you have that drawing. So this is, say for example, is minus 3 by 2, and here is a tip without applying this 5. Okay, so that means you have at this place something like this going, and obviously this graph is symmetrical about whatever is this line. This is symmetrical about this. Okay, and what we want is shifted down by 5, right? So you have negative 5 here, and this is a negative 5. So it is shifted to this. Entire thing is shifted to this. So this is a shift. Okay. So you have a graph now. Exactly this line is parallel to this, and this line is parallel to this.
So shifted down.
Yeah, shifted down. Okay. So that's how it gets shifted down. Right. So this graph is the one which we say mod of 2x plus 3 minus 5. Okay. Now for example, I have a question from here, and it says solve mod 2x plus 3 greater than 5. So there are two ways of looking at it. This is one way of looking at it, is the way we have done previously, which means mod of 2x plus 3, get the 5 to the other side, minus 5, okay, greater than 0. The other one is just solve as is, like, so you will have a 5 line. That means the curve of mod 2x plus 3, okay, above y is equal to 5 line. Above, because remember, like we did that linear programming, the inequalities and then shading the regions and all in 11th standard, the AS levels. That's a graphing the inequalities and all the stuff. Okay, so anyway, since this entire thing has to be greater than 0, let's look at this first method. Then we are going ahead with this part is not included, only this part is included. Okay, this is included. We want the not included. Yeah, okay, the shaded region included. Let me write that first. Shaded included. Okay, here shaded included. Okay, I think they do the other way, right? Let's go back. We did the other way, I think. Yeah, shaded is not included. We want, then this is not included. Okay, so because that's a negative part of it. Understood, right? So this sketching is the one which actually they may give a lot of questions on this. You got this, solve 2x plus 3 is greater than 5. That means whenever this is solved here, in fact you have to show graphically also. And how do I show non-graphically? Let us look at this now. Okay, if I have to show non-graphically, how do we have to solve it? That means algebraically. So you will have mod 2x plus 3 is greater than 5. So when you square it, obviously you will have 2x plus 3 whole squared, okay, is greater than 25. So when you take square root, then it's 2x plus 3 is greater than plus 5, right? Plus or minus 5. So then you solve in the same way. You have two approaches. So 2x plus 3 is greater than 5, which implies 2x is greater than 2 and x greater than 1. Or say 2x plus 3 is greater than minus 5. That implies 2x is greater than minus 8, x is greater than minus 4. So you have two things, x is greater than minus 4 and x is greater than 1. So when you actually put on the number line, this is minus 4, this is minus 4, and you have this is plus, say for example 0, and this is 1. And he says for greater than 1, that means all these things it will satisfy. So greater than minus 4 is this anyway. So which actually satisfies both is x must be greater than 1. If x is greater than 1, then it is definitely you'll have greater than 5. So go back to the graph. So when we look at this value, when this becomes 0, so this becomes 5. When this becomes 5, this becomes 0, right? 5 minus 5. So 2x plus 3 equal to 5. So that's what x equal to 1. So that is this x equal to 1. Huh. This you are getting this to be minus 5. This, yeah, either plus 5 or minus 5. When you put minus 5, you get this value, which is x equal to minus 8, which is minus 4. So x equal to this 1 and minus 4. Okay. So why I am saying this? Okay. So we got for any value greater than 1, for any value should be less than minus 4. When you look at this next one, the greater than minus 5 is the one which is affecting. If it is a less than minus 5 instead of greater, then you'll have less than minus 8, you'll have less than minus 4. Okay. Understood? Not understood? Or confusion? Go back. Yeah, this is what we had. This is what we had. This is what we had, right? Huh. So what do we mean by greater than minus 4? Greater than minus 4 is this side. This is greater. This side, if you go, it is called less than minus 4. So, but x is equal to greater than 4, minus 4 means, for example, x equal to minus 3, and I put x equal to minus 3 in this. So 2 into minus 3 plus 3, which is equal to minus 6 plus 3 is minus 3. Correct? Huh. But then, because we used minus 5 here, minus 3 is actually greater than minus 5, which is correct. This minus 3 is the left side, this is minus 3, is greater than minus 5, which is correct. Okay, which is correct. But is that what is included or not included in our graph? Go back to this. If I have minus 3 here, this is minus 3. When x equal to minus 3, I am getting into not included, isn't it? I am getting into this area. But we are solving for not included. I mean, it should be greater than 5. That means these values. So this value will come here. That's the reason. This is the only catch when you are solving it. You have to have no plus 5. Okay. So you should take it as 2x plus 3 less than minus 5. This is 2x plus 3 greater than 5, and you have to take 2x plus 3 less than minus 5. Okay. If you are this is a confusion, you get algebraic solving. Okay. When you are solving algebraically. So whereas you have done it graphically, right? It was easy. You plotted this graph, okay, and you use that greater than symbol, finished it. Okay. So we will come back to this based on what they discuss in the class. Okay. But I just wanted to first make sure that the fundamentals are given for absolute functions. You have math immediately today, after this. Okay. So you want up to 10 o'clock or 1 hour class or 1.5 hour class? Oh, I see. So we'll have 1 hour then, 9 to 10. Okay, because 10. Yeah, fine. Okay, so what time is it now? Another 5-6 minutes is there. Okay. So you want me to review? I can go back and then complete revise. Yeah, let's see. So this is the first one. Okay. So exponents, logarithms, and related functions. Related meaning exponential functions, logarithmic functions. We are done. Absolute or the modulus functions is the today's topic, and we have got first thing, just like the way we learned exponents and logarithms, you have to have the value, what it means. So mod of minus 5, we read that as a modulus of negative 5 or mod minus 5, and its value is, this is the value of that is 5, positive 5. So in general, if you write f of x is equal to mod minus x or f of x is equal to mod x, this will have only the positive value. There is no negative value. Only positive value, meaning is above the x-axis. There is nothing below the x-axis. So how do we visualize it? You have y is equal to x graph, that is this y is equal to x graph, and then cut off the negative part and then flip it over to the above x-axis, okay, or above this point. Then you get the graph of y is equal to mod x. Okay, so I just gave the values in a tabular form, and that's how we, when you plot it, you will see these things coming exactly the same way as we did in the last page. So you get this as f of x is equal to mod negative x, also same as f of x is equal to plus mod plus x. Okay, then there will be something more on translations, transformations. F of x equal to mod x plus 2. We know that x plus 2 here indicates that it is shifted left by 2 units. So that's what we gave in the next page. It goes shifted by, actually I said it's shifted to this minus 2. Here itself I written tip is shifted to minus 2. Then we talked about the 4 variations. F of x is equal to mod 3x, f of x is equal to mod negative 3x, f of x equal to 3 mod x, f of x is equal to minus 3 mod x. Sketch of a and b and c are identical. D is different. D has a negative value because this is negative coming from this minus 3. So if I have f of x is equal to just x and g of x is equal to negative x, so one is with a positive gradient, that's f of x, g of x is a negative gradient, and that's how this graph looks like. But within the mod, whether it's a plus x or minus x, graph looks same. So we try to actually plot this. If we have f of x equal to 3x, that is this, and negative 3x, it is reflected along this x-axis. So there is no positive value for g of x because this minus 3 is making every value as a positive, sorry, as a negative thing. Okay, so then we ask, like, is this both are identical, mod 3x plus 2 and mod of minus 3x plus 2? I said you simplify this algebraically, take a bracket out, sorry, negative out from the bracket, and you get minus 3x plus 2, and therefore both are identical. Okay, so then we have 3 variations. One is with a positive 1 gradient, positive 3 gradient, and positive 1 over 3 gradient. These 3 graphs look like that. Okay, then we talked about a concept of squaring and taking the square root to get the both positive value and negative value. So we have this mod 3x minus 2 equal to 5, and this is how we do algebraically. If you are to do graphically, just draw the y is equal to 3x minus 2, y equal to 5, then find the intersection. We'll come back to this in case it's covered. So you'll have plus 5 and minus 5. This is in the equalities. Inequalities we covered at the end. We can't take straight away. So when you put x 3x minus 2 equal to plus 5, x equal to 7 by 3, x equal to minus 1. Then we tried to solve a question, and you did this thing, which was correct. So then I tried to explain, if we have to sketch this, you sketch first 2x plus 3 and shift it down by minus 5. Then we tried to go into this. This is what we covered at the end. If we have an inequality like this, so how do we? So this is the one which is not included. We solve this inequality graphically by saying that this is not included, everything else is included. Everything else is included, meaning this part is included, this part is included. That means this part is, whatever is coming here is not included. Okay, so that's how we try to go with the algebraic solving. Then I explained, if you take plus 5 here, you get x equal to greater than 1, and when you actually take the negative value of it, okay, so here when you have 2x plus 3 is greater than negative 5, okay, so you have to make sure that we have to use a less than symbol, and that's how you get 2x plus 3 is minus 8. This is because you are taking these two values and you get x equal to less than minus 8, less than minus 4, I'm sorry, less than minus 4 goes this side, and algebraically also that's how you will plot it. Okay, any questions? You got everything. All right then, good.